and welcome to another episode of Math Made Easy by Mrs. Roberts. What you will see here on the right-hand side of the screen are the Pythagorean identities. I did borrow this image from the internet. And our Pythagorean identities are sine squared of theta plus cosine squared of theta equals 1. And if you know that one, the rest of them are just a matter of rearranging or manipulating the original one. So if you know the first one, you're golden. So if you divide this one by cosine of theta, you're going to get this, 1 cosine squared of theta. You're going to get 1 plus tangent squared of theta equals secant squared of theta. And if you divide the original one by sine squared of theta, you are going to get this one, 1 plus cotangent squared of theta equals cosecant squared of theta. And then each of these can be rearranged like this. So all of these are derived off of that original sine squared of theta plus cosine squared of theta equals 1, which is derived from the Pythagorean theorem, which is why we call them Pythagorean identities. So in this video, I would like to go through a couple of challenging verifying problems. And so the first one I would like us to verify is I want us to verify that tangent squared of x minus sine squared of x equals tangent squared of x times sine squared of x. So when you are working through these problems, it is important to know that there are so many different ways to start this. You can get things in terms of sine and cosine. You can try to get things in terms of a Pythagorean identity. You can use reciprocal properties. You can use quotient properties. Whatever works the best for you. Now, my first piece of advice is going to be start with the more complicated side. So let's start Mrs. Roberts' advice. This is going to be my advice column. And so start with the more complicated side. That's my first piece of advice. Let's see if I can make this so it's easier to see. Oop, oop. Okay. That's all right. So we have to determine what side is more complicated. They look almost identical. We have tangent squared of x minus sine squared of x, and we have tangent squared of x times sine squared of x. What one's more complicated? Well, tangent squared of x minus sine squared of x is technically two terms. You have tangent squared of x and you have sine squared of x. Tangent squared of x times sine squared of x is technically one term. And so I would say that this function here is more complicated. I would say that's the more complicated side. And so let's start with this because it's easier to make something that's complicated less complicated. It's harder to take something that's less complicated and then expand it into what you want it to be. It's not impossible, just to me it seems a little more difficult. So, what am I going to do? How in the heck am I going to figure this out? Well, tangent squared of x can be in terms of sine squared of x, and then both of the terms would have something in common, so I could factor. Let's see. If I rewrote tangent squared of x using a quotient property, I could say tangent squared of x is the same thing as sine squared of x over cosine squared of x. And of course, I can't forget about that sine squared of x. I could say that these are equivalent functions. Now what? Oh, this term and this term both have a sine squared of x in them. So I could factor out a sine squared of x. And if I factor out a sine squared of x, well, this term is left with 1 over cosine squared of x. And sine squared of x is left with 1. Well, I kind of have one term now. because I have sine squared of x times 1 over cosine squared of x minus 1. So if I could somehow get this to be tangent squared of x, I could be done because I have the sine squared of x here. How in the world am I going to get this in terms of tangent squared of x? Oh my goodness, there's a minus 1 here. What if I could use a Pythagorean property? What if I could use this property? Because that property equals tangent squared of x. Well, let's see. What's 1 over cosine squared of x? Using the reciprocal property, that is secant squared of x. And we have it. Look at that. Secant squared of x is the same thing as tangent squared of x. And so this is the same thing as this. And we did it. Awesome. So my advice, start with the more complicated side. Then look for identities or properties that you can substitute in. Oops, I don't know why I put a space there. You always want to keep in mind the end product. That's what I put on there. Always want to keep in mind the end product. Okay, let's try another one. Let's try one more that you kind of have to think about in a different light. I'm going to erase this so that we have some space. Oops. I wish I had a quick, easy way to erase. I probably do. Let's be real. I just don't know how yet. We'll get there. And then I'm going to erase this little check mark. Okay. So this problem here that we're going to do is I want us to verify that sine of theta times tangent of theta plus cosine of theta equals secant of theta. That's kind of ugly. Well, this is what I notice. I notice that this side is more complicated. So let's start here. So this side is more complicated, and we want to get that down to just secant of theta. I think we can do it. Let's try. So sine of theta times tangent of theta plus cosine of theta. Maybe let's get tangent of theta in terms of sine and cosine. And we can do that using the quotient property. So this would be sine of theta times sine of theta over cosine of theta plus cosine of theta. And one thing hopefully you've noticed is I am very deliberate as to where I put these things. So sine and sine are in the numerator. This cosine's in the numerator. This cosine's in the denominator. So I'm very deliberate in where I put these things to make sure that I know like where things cancel out and things. Okay. Well, I have a fraction here, and in order to add fractions, I need to get a common denominator. A pretty good common denominator would be cosine. And so let's go ahead and multiply this by cosine over cosine, because cosine over cosine is just 1, and multiplying by 1 does not alter the equation whatsoever. And so we end up getting sine squared of theta plus cosine squared of theta, and all of that is over our common denominator of cosine. Oh my gosh. This is so cool. We are basically there. What is sine squared plus cosine squared? Ding, ding, ding. That's a Pythagorean identity. And so this is 1 over cosine of theta, and our reciprocal property tells us that 1 over cosine of theta is secant of theta. And we did it. So again, start with the more complicated side and then look for properties you can substitute in, always keeping the end in mind. I hope this video helped you.